we are going to discuss about the topic equations of motion. These equations of motion, we are going to take three equations through which we can solve all the sums and we can find out time interval, we can find out the velocity, we can find out the acceleration, we can find out the distance covered. So, what are the three equations of motion? So, the very first equation of motion is V equal to U plus AT. This equation gives the relationship between velocity and time. Explains about the relationship between velocity and time. And the second equation is S equal to ut plus half at square. This equation gives the relationship between position and time. And the third equation is power 2 minus u power 2 equal to 2as, which gives the relationship between position and velocity. Position and velocity of an object. So these are the three equations of motion, where u is the initial velocity, v is the final velocity, t is the time interval, a gives you acceleration, and s is the distance covered. So, under which circumstances we can apply this equations of motion? Means the object should move in the conditions for applying this equations of motion are: the object should move in a straight line. And the second condition is the object should move with uniform acceleration. These are the two conditions that the three equations should satisfy. And what is the acceleration? Is the rate of change of velocity. So v minus u by t. Based on these equations, we can solve so many sums coming under this motion chapter. Now we are going to discuss about a problem related to equations of motion. So let's see the problem given. A car accelerates uniformly from 18 km per hour to 36 km per hour in 5 seconds. You have to calculate the acceleration and the distance covered by the car. So, here it's clearly given as uniformly accelerated. Uniformly. The condition for applying the set of equations from equations of motion are, one of the condition is that the object have to move uniformly. The object have to move with uniform acceleration. So it satisfies this condition. So we can apply the equations of motion. So whenever a sum is given, we have to write the given data. So given data u equal to 18 km per hour. That we have to convert to, see here it's given in hour and time is given in seconds. So we have to change the given data velocity u and v into meter per second, so that only we can apply this time. Given u is equal to 18 km per hour. What's the condition for converting kilometer per hour into meter per second is we have to multiply the numerical value by 5 by 18. So 18 into 5 by 18. These two 5 meter per second. So converting final velocity 36 km per hour into meter per second, we have to multiply by 5 by 18. So this 18 will go 2 times to 36. So 2 into 5 is 10 meter per second. So the given data t equal to 5 seconds. Now we have written the given data. So how to find the acceleration? The formula to find out acceleration A is equal to v minus u by t, where v is the final velocity and u is the initial velocity and t is the time interval. So let me substitute. Final velocity v equal to 10, initial velocity u equal to 5. So 10 minus 5 by 5. 10 minus 5 is will give 5. So 5 divided by 5. Ratio of 5 and 5 is 1 meter per second square or 1 ms power minus 2. This is the answer for acceleration. So how to calculate the distance covered? We all know that the distance covered is represented by the symbol s. So s equal to ut plus half at square. Here we know the initial velocity u time t plus half a. A also we calculated now as 1 ms power minus 2 and again t we know as 5 seconds. Substituting all those given data in the formula, u is 5, t again is 5 seconds plus half a what we have found out is 1. So 1 t again is 5 square. 5 into 5 is 25 plus half into 5 over 2 is again 25. So 25 divided by 2 will come as 12.5. 25 plus 12.5 is 37.5 meter. So this is the distance covered by the car. So using two equations of motion, we have calculated the distance covered by the object. Like this, we can apply equations of motion for any object that is moving in a straight line under uniform acceleration. Hope you understand. Thank you.